Another electronic computer is EDSAC. Here's the picture of EDSAC. It somehow looks like EDVAC. The full form of EDSAC is Electronic Delay Storage Automatic Calculator, and it was early British computer. It was constructed by Maurice Wilkes and his team at the University of Cambridge Mathematical Laboratory in England in 1949. EDSAC was the second electronic digital stored program computer to go into regular services, means in regular use. Here is video showing EDSAC.
Welcome to the Edsac gallery. What you see here is work by a team of volunteers building a replica of an early computer at Cambridge University. We're busy finishing the machine. We hope it will be working soon. And at that point, we'll be able to show you what computing was like in the 1940s. And you might want to try writing programs for the machine yourself.
These men are now graduates of the university. Most of them will be leaving Cambridge for good to start a job in life. A few will stay on to continue their researches.
In 1947, scientific research at the university was picking up after the end of the Second World War, a war that had produced Colossus as part of code-breaking here at Bletchley Park. In the university's mathematical laboratory, Maurice Wilkes and his team, inspired by John van Neumann in the USA, built this, the world's first practical electronic digital computer of the modern kind. A computer that helped win several Nobel Prizes and pioneered computing in Britain. Edsac provided a computing service for academics ahead of anywhere else in the world, unlike the slightly earlier Manchester baby computer, which was purely an experimental research machine.
The Edsac had begun to work in May 1949, and we had developed a system of programming based on the use of a library of subroutines.
What does a computer of the modern kind mean? Almost any computer, like this smartphone, has features in common with Edsac. First input. Edsac took its data and its program from punch paper tape. It held these together in memory, so it was called a stored program computer, unlike Colossus, which was hardwired for just a single purpose at the time. It output its results to a teleprinter. And the Edsac pioneers were also pioneer programmers, developing a mnemonic programming language and a library of subroutines which users could call on to aid their calculations. In our replica, we used 3,500 vowels, all authentically dating for the 1940s. They provide the computing logic, handling ones and zeros, the binary, just like any modern computer. Edsac stands for Electronic Delay Storage Automatic Calculator. That's because Edsac used so-called delay lines for its memory. In these, bits pass through as a stream of sound pulses through a medium. In the original Edsac, they used mercury as the medium, stored in long metal tubes called tanks.
It was possible to exhibit the contents of the memory on a cathode ray tube. The instructions are being read and going into the store. The next tank. And here you see the numbers in the store changing as the calculation proceeds. And it was, I think, the first film showing the operation of a stored program computer to be made.
The tanks were held in wooden boxes called coffins, which have long since disappeared, but we've created them like this for our replica. In our coffins, we're using so-called nickel delay lines, like this, a later technology which works to the same principles. In a nickel delay line, data travels as pulses from a transmitter along a coil of wire to a receiver at the other end. Nearly a third of Edsac circuits are concerned with circulating data through the memory. And of course, everything has to be carefully timed. So here is the central clock, the beating heart of the machine. Let's move from the front of the machine to the next row, which is called main control. And just like the central processor in a modern computer, it fetches instructions from memory, decodes them, and sends data through to the next row, which is called the arithmetic unit, and has the circuits that know how to add, subtract, and multiply numbers to carry out the user's calculations. So, Edsac has all the features of a modern computer: input, output, a memory or store holding program and data, a central processor, and an arithmetic unit. This is the so-called von Neumann architecture that inspired the Cambridge pioneers in the 1940s. Edsac was kept going by a team of dedicated engineers. Today, our dedicated volunteers are working here many days a week to get this authentic replica working. They built parts of the machine at home in their sheds and slowly brought them here, where we're now into the process of integration and commissioning. Like the pioneers, we run into unforeseen teething problems which we're having to solve. We're way out. This is a difficult beast to recreate. Almost nothing of the original survives to guide us. Just a few circuits, a memory tube, some photos and notebooks, and the memories of just a few surviving users who used Edsac 70 years ago and remember it still. So, with fingers crossed, Edsac should work very soon. Watch this space.
Here we have finished the video of EDSAC.